Alright, so as interesting as this box of water is, let's go make our actual source. Or rather, I should say, our initial state at least. So make another geometry node here. I'm going to put this one right next to our liquid sim, because this is going to be liquid source. Yet another green cube. So liquid source is going to be basically a kind of flat, initial calm river state. So let's go get the collision geometry. I'm going to get the VDB version of it. And remember, you can always just grab it from here. So there that is. In fact, maybe to make this a little bit easier, I'm going to say I turned on show all objects. I want the ground to be on here. Instead, I'm going to make a box. So this box, I kind of want to fit it to here. The idea being that I'll make it wide enough that it spans here. I'll make it long enough that it is, this. So we're modeling essentially the river by starting with a cube, and then we'll subtract the actual thing from it. So I'm going to make this, I guess, to make everything nice and even. It can be 9.9 units long, because remember the whole thing was 10 units long before. We moved everything -2 over before, so we can figure that's the same. I want this to be fairly shallow. The more shallow the water is, the more rough it'll be. I'll just round this one to 0.6. Deep water tends to be still. Still waters run deep, as the saying goes. We don't want that, so we want shallow waters. It'll be more frothy and interesting this way. And honestly, less particles to simulate. Am I right? So that's cool. And then the width here doesn't matter as much. I'm just going to round it for the sake of argument. But, the point is that that's going to get booleaned out anyway. So let's get to that. So we have that. I'm going to say let's actually make a VDB from polygons here. This is going to be another time where we're going to take this parameter and put it here. So I'll say relative channel references, like so. So you can see it turned into a thing. And now I'm going to hide everything else. So there we go. So now we just have a sine distance function of our thing. And now we have the other sine distance function here. So I can do a VDB combine to paradoxically subtract by going to SDF difference. So this is a pretty low res thing here, but you can see that it kind of has a shape on the side, and it kind of has the riverbed dug out from it. So that works. And that's pretty much all we need to do a flip source. Flip source will take that. A flip source takes in either polygon geometry or a surface, aka sine distance function, volume like so. Once again, we need the voxel size here, like so. I did say voxel size before, right? Okay, good. It will also create particles for us, like so. We can't see them because they're being covered up by the volume. If you like, you can drop a primitive sop down, and that has a adjust visualizations thing here. We can just make it invisible. So now you can see it. So the VDB is still here, the surface, but now we can also see the points. Of course, as we make the separation be less, there's a smaller gap between them, and therefore there is more of them. I'll keep it at this default one here for now. While we're here, we have a river that's going to go this way, from left to right. That is apparently the positive x direction. So the flip source has a little convenient thing here. Velocity, we'll just say 1. So it goes, they all have a little velocity vector now that says 1, 0, 0. So they'll have a v attribute. And that's pretty much all we need to get this show started. I can say initial state. Come over here to the liquid sim. The viewport is showing me whatever the last thing I clicked on was, as you can see. in case that wasn't clear, the flip object itself has this initial data tab. Wish my monitor was bigger. So initial state, initial type, surface SOP, that's what this is, but really we want to do a particle field. So the SOP path again, just drag this to here, and it'll just start with that. And that's pretty much it. This also has an initialized velocity thing here that you could use. I think it's just as well that we do it out here anyway to do it as an attribute. You know, again, we are saying that our initial state, or that our velocity is going this direction because we set it up this way. You might have something more complicated, and you might need to set different velocities up, which you can do in many ways, and actually we'll kind of do one in this lesson. Anyway, this is enough to say that I'm going to turn on the I'm going to put the display of our ground thing back on while we're in the sim. Go into our camera, press play. This will be the fastest simulation you ever see. It just does it in real time. Yeah, it literally works. The river is behaving as expected in that it's going to the right. It gets deleted when it gets to the right. There's no new river coming in over here. So these particles move to the right, then kind of encounter resistance from the particles that are still ahead of them. And then they kind of just give up and kind of backwash back to the left, where they also get deleted. So that's cool. Let's turn on the little clock thing here. That means peg this to real time. If it's off, it'll play as fast as it can. If it's on, it'll play it back actually at 24 frames a second if it can. It's not moving very fast though, even in this sense. So I'm going to say on our flip source, change it to 2. And now let's see what we got. This is probably better. If I were to back it up, here we go. You know, we want this river to move swiftly. That's the point of this lesson, to generate whitewater and for other things. So we'll try 2 meters per second, I think, is what that is ultimately. So let's see what that gets us, and we can always change it later if we need to.